work for the NT Performance Group. And, we're going to be talking about what we went through when MSCOM switched over to IS5. So, started out, everything looked great. We were going off and telling everyone, and it really was me, because I own Internet Services Performance, that NT5 is 40% faster on static, and if you look at the ASP performance, Tai, who's in my team, he drove performance up by, it's 3x now. Right? In proc is 190%, out of proc is 220% higher. So we figured, look, ASP looks fantastic, static's 40% higher, and networking is better everywhere. Right? And this, all through the entire stack was supposed to be so much better. And in general, we said everything scales better going from NT4 to NT5. But lo and behold, MSCOM puts NT5 up on its machines, and they say performance degrades. They say that what they go off and do is hit key scripts periodically. So during the course of the day, they'll hit some scripts that they use as their benchmarks, and they measure the response time for those. And they found that under load, NT5 machines were giving them response times that they found unacceptable. So they have some metrics. Said this is too much. People aren't going to wait a minute and a half for these pages to load. And what they would do is, and this is what they found helped, they would pull the NT5 machines from the clusters. The way MSCOM is configured is they have round-robin DNS hitting 7 clusters, and each of these 7 clusters has 4 or 5 machines running NLBS. So it's fairly load balanced across them. But they would go off and pull NT5 machines from clusters and reboot them, and then put them back. And of course, this goes completely against what we were telling customers, right? You don't need to reboot NT5 now. Well, at least not as often. ITG got called in because they were the ones helping deploy NT5 everywhere. And I know this says NT5, but it's still NT5. Right? And they found that ASP queues were building up during the busy periods. So of course, we start out as, and what does MSCOM says? Goes to Brian V and says, we're not deploying NT5 until you fix this. So Whale got called in, and since this is internet, right? Here I am. Of course, the first thing was, everybody starts guessing because we have no idea. So look at perfmon, say, let's collect whatever counters can provide us some more information, and these are the ones we typically would collect. CPU, other resources, memory usage pool is something different between NT4 and NT5. Look at the page faults, the interrupt rates. Okay, are we just doing more network I/O? Oh, maybe NT5 is so much faster, it's pulling in requests faster, so it's getting more load. That's why queues are building up. Sure. Look at the IS counters, everything. So we got logs over 21 hours. One NT4 machine, one NT5 machine, same cluster, load balanced, so it's supposed to be getting the same load. We found that the NT5 load was 28%, NT4 load was 12%. The CPU usage. And we looked at the cache hit rates. Maybe the NT5 cache isn't doing as well. No, it's about 70% for both ASP and static on NT4 and NT5. So we went off, did this for other machines. Maybe this is a fluke. But data was fairly similar across other machines. So now we're looking at this MSCOM environment, and we know we cannot repro this thing in the lab. Right? We have to go out to Cannon Park and try to run there. They have 60 databases that they hit. They have thousands, hundreds of thousands of ASP scripts. And the load just varies throughout the day. There's no way we can take this in the lab and repro this. And of course, Microsoft.com wants its machines live. They can't just let us go and take over these machines because they are our corporate presence on the internet. And moreover, they are not willing to say, okay, these machines aren't performing well, but we'll keep them there so you can keep monitoring them. We weren't allowed to change the setup. We couldn't say, okay, when we have NT5 machines, just take the ASP load or just a static load. We couldn't vary these things. So we had to go off and monitor live machines. We had kernprof, we had kernrate, we had perfmon, and then we got Adrian Marinescu, who owns the heap, to give us private instrumentation. I'll come to why this was needed. And we had sysmon from our workstation. So the first thing we looked at was CPU data, because it stood out. it's higher than NT5, 28% versus 12% on the 21-hour logs we looked at. And one thing we knew was the static cache miss cost is higher than IS5. It's because IS5 moved to a new cache model. The old cache model on IS4 was a file handle cache. They'd open the file handle cache and they'd call transmit file, which is tailor-written actually to take a file handle and send the file data over a socket. The new cache model opens the file handle, reads in the data into user caches, into the user buffer, and sends it out from there. And just because it has to open the file, read the data in, the cache miss cost is higher than it used to be on NT4. We looked at the kernel rate data, and the heap was implicated. Now, part of this is the heap. Part of this whole static miss routine is the heap. You allocate space, you read in data from the file. So we said, okay, we'll just go off and turn the static cache off, and let's see how it does. Well, CPU usage was still higher than NT5. And the heap was still high in kernel rate profiles even after we'd done this. So here we are. So the static miss cost is high, and it's higher, but it doesn't explain the degradation. So we look at the next thing, XML, right? If it comes out of building 42, it's got to be a problem. This has been, okay, Ole, COM, XML. My goodness, and yes, this turned out to be very high CPU cost. So Chris Ashton helped us. He's part of the team, and he said, okay, I put it under load, it deadlocks. Right, the garbage collection will deadlock under load. And said, okay, this has to be the problem, right? Well, they gave us a private XML. We put it on NT5, and it was still slower with the private XML when they fixed a lot of these problems. So XML was, well, it should be a severe performance problem, but unfortunately wasn't the cause of the regression because it was as bad or worse than NT4. So we had to, we hated to do this, but we had to rule it out as part of the problem. Well, part of this problem. Then there was the thread pool. We noticed we were getting far more threads on NT5 than we were on NT4. This is the STA thread pool. If you know what the ASP model looks like, IS takes the request, hands it over to the STA thread pool, which handles ASP requests. And we found that they were running many, many more threads. There had been changes, so we went off and we got private binaries which said we will limit the number of threads in the STA thread pool. It helped, but didn't solve the problem. So just having fewer threads where you had more will help the problem, but unfortunately wasn't enough. So here we are. We still see long ASP queues, and we've managed to rule out the usual suspects. Okay. There's high heap activity, and we know the NT-heap hasn't changed much because you can actually go and do a diff on the NT4 and the NT5 code, and there isn't much change. And of course, IS claims we didn't do anything. We haven't changed any heap usage. So I got desperate and I said, one thing I know we haven't looked at a whole lot is cache misses. And we've just looked at the static cache misses. What about the ASP cache misses? I said, okay, I'll take 1,000 copies of the same ASP script, and I will hit one first. Just have a load generator, hit one script, keep hitting it over and over again, have 10 clients hit it. Then I'm going to hit all 1,000. And of course, I get much lower throughput. But then the surprising thing was, I wasn't expecting this, is when I hit one again, throughput was lower than it used to be. So if I get 10 requests a second when I hit one to begin with, and I get 5 when I hit 1,000 all at once, I would get 7 or 8 when I went back to hitting just one. So,
sorry, were you doing this on a live system?
No, this was in the lab. This was in the lab. So whatever it was that hitting 1,000 ASPs was doing, was causing permanent damage. And I did not see this behavior on NT4. So when I went back to hitting just one script, I would get the performance back that I used to get. So this essentially was the key. Now, I had no reason to do this, except I said, okay, I'm desperate. Let me try this. And this was the key to solving the whole issue. Okay, so it's the heap. It's from the kernel rate. We know that the heap usage is way up. But something's changed, so we go back and say something in your ASP path has changed. But what's changed? Turned out I went to Bilal, who used to be in the IS group, and I said, oh yeah, I remember. We changed our heap allocation. We changed it from our private heaps to MSVCRT. Now, of course, they're not. If you look at it at a high level, the heap, they can still say, well, the heap usage hasn't changed. except which heap they go to has changed now. And as it turned out, when we dug a little deeper, the intermediate caching behavior had also changed. Moreover, the script engines had gone from linking to libcmt to linking to MSVCRT. That means they used to have private heaps. They all go to the VC heap now. So look at what's happened. All these other heaps are now all being directed at the VC heap. And it buckles on there. Well, part of the problem was ours. We'd gone off and told everyone, look, the heap sucks, go off and cache allocations. Well, you go off and cache allocations from a shared heap. What do? You fragment it. Well, as it is, a heap's fairly fragile. It's easy to fragment. And then when you introduce this lifetime variation in the allocations, some of the allocations are cached, others are short-lived. You have the problem of a fragmented heap that you're allocating and freeing from. So everybody had now targeted MSVCRT. And this was what we were seeing. A lot more time spent in the heap. The ASP cache gen was causing fragmentation of its own and heap usage, because we'd free whatever heap allocations we were caching, and then allocate some more. So it was hitting us twice. So, well, we asked, and Dave Probert, who owns this, said, app compatibility, we cannot change the heap until black go. So we got IS to add private heaps. ASP DLL allocations, this is the ASP allocation itself, was directed to private heaps instead of MSVCRT as much as possible. Script engines want to keep linking to MSVCRT because of size concerns. We added memory to machines just because IS5 has a much larger footprint. And when all of this was said and done on two identical machines, NT4 would give us 59 requests a second, and NT5 was 74 live machines at MSCOM. So what are the lessons that, now that all of this is said and done, what are the lessons we had quality concerns about our tools. Kern rate was giving us the wrong data for a while, and it did set the investigation back. And a lot of our tools just weren't appropriate for this sort of work. The investigation took us far too long. This is really a process concern. It took us several weeks to figure this out, to do all this. And as I said, in the end, it was out of desperation. We just went off and tried something. Our lab workloads are clearly not representative. There's a big disconnect from what customers are doing and what we're looking at in the lab. And yes, the heap, man, it's been with us for a while as a major performance and reliability concern. One of the things that Whale said after this is, look at this. Maybe this is why, this fragmentation is why our customers are going off and rebooting machines. Because things slow to a crawl, and the only thing they can do is go off and reboot the machine, and you get a fresh new heap of this. So what's the problem with the tool qualities? Well, we couldn't get our symbols to stay matched, especially when we put private binaries on it. Once we BB2 symbols, we have problems resolving symbols. We've seen this with kernprof. At times, we've seen this with kern rate. Some of our kern rate data was just wrong. We had to fix it, but it set the investigation back. Instrumentation is really expensive. We can't take IceCap binaries and put them on a live site. So the tools we have today are, well, this is part of the tool quality problem. There's, of course, the lack of tools. Most of our tools are geared to desktop issues. Page faults, CPU usage only for a small while, do the stuff on a desktop machine in the lab. We had just about all the data we were getting through private instrumentation. The heap, especially. And this is just not possible with customer binaries. It's not really, this was MSCOM. We can't really go off to just any customer and ask to put, and be allowed to put private instrumented binaries on the side. And all of this is really hard to do on a live site. Today we have no way to relate resource usage to an activity. So for instance, we cannot say we can say IIS or ASP.dll, but IIS is taking this much time. The only way we have to tie CPU costs to ASP scripts is to take the ASP scripts out of proc and that introduces its own problems. Our profilers are flat. Yes, we can tell allocate heap and free heap are taking up a lot of time. We just don't know who's calling into this. Right? We have 50 heaps in the system. We have 1,000 entry points. Who's calling? Who is causing all this allocation free activity? Why? Or is it just a lot of allocation that's happening, or is just allocation free taking a lot more time than it should be? Just the process, and really no good solution to this. The resolution was just, let's go off and try this. I just went off, did something in the lab, ended up solving the problem. So it just had a very ad hoc feel to it. Just working on the live side was very difficult because all of our processes are designed to work in the lab. Okay, take things apart, instrument this, instrument that, put it in, have a constant workload. So here we are working with the live side with varying workloads, and we found it very difficult to work there. And of course, the whole thing was, okay, it's COM, it's OLE, it's XML, it's a desktop component running on a server. It must be the problem. Right? And yes, 80% of the time this is the case, but this whole XML issue set us back again for a while. And just workloads, big problem. What we're looking at in the lab has very little to do with what the customers are seeing on the sites. We knew this was a problem. Cache misses. We've been talking about looking at cache misses for a long time. Just hadn't had the bandwidth to do it. Of course, MSCOM's really changed our focus on these issues now. We've had this bias of looking at industry benchmarks just because marketing would like us to look at them and make sure that we do well on them. If you've been looking at the Foster alias today, you know what's going on with the SpecWeb 99 issue. It's a real pain. It's not a very good benchmark, but we use SpecWeb 96 to our advantage. Well, it's not very good, but we did well on it. So now it's payback time. Right? The extreme workload in MSCOM itself, it's just not something we'd expect even hardcore customers to be doing, hundreds of thousands of ASPs. It's just not expected. And again, there's the complexity issues. You have a complex workload, it's hard to drive performance improvements using a complex workload because it's hard to abstract. The heap, what can I say? It's a real pain to deal with. It's really easy to fragment, and of course we tell people to go off and cache allocations, bytes right back. There's so many concerns with the heap. We have there's a speed concern, there's a size concern. We try to do anything about size, about speed, our workstation colleagues say, okay, if it's hurting size, it can't go in. Scalability issues, size issues, all the compatibility issues. Big problem. We put in look-asides for the small allocations, broke several of Microsoft's apps, just because realloc could now possibly give you a different address than you started with, and a lot of VB runtime wasn't prepared to handle that. So there's a lot of bad news.
So when do you fix that? There's
a registry setting that says don't use look-aside with these applications. If you go off and look, I think one of them is I think Encarta is one of them. It's compatibility, backwards compatibility. It's a lot of bad code. A lot of it is ours. What do you have to do?
And that's going to stay in there forever, pretty much.
Well, with Blackcomb, the plan is we're going to break so many applications anyway. Let's go off and fix this. But again, it's Blackcomb. It's
easy for the plan to be bad.
yeah. Now exactly. It's like let's shut up the perf guys for now. We'll tell them Blackcomb. We'll talk to you when Blackcomb comes around, and then let's see what happens. Debugging is a big issue. Right? Whatever heap we provide in there has to have debugging support. Just because heaps leak and you go off and then there's the variety of workloads. We looked at different heaps, and there's not one that will work for everything. Do we want to provide several heaps in NT? That's again the issue. Right? We have to support all of them too. So just and by far the biggest issue here is backwards compatibility, but there are all sorts of other issues that go with trying to fix the heap. So what are the improvements we're trying to make to the tools? Well, we need better profiles, and we hope we can help with that. I know we've been talking to Ken about this. We need profilers that are geared to server issues, because we'd like to be able to collect data for hours rather than seconds. Anyone that's used ice caps knows how long you can collect data when you're really hammering the application you're trying to ice cap. Attribution is really important for us. We need to be able to walk the stack. Unfortunately, it seems to be getting all the more expensive by the day to get attributed data. The changes going into the compilers that'll make it even harder to do this live. But this is really something. Tracing, we have the capacity planning effort that's putting in WMI tracing. So what we're trying to do is match. We take activities and say this is the resource usage pattern for this particular activity. This will also help us with capacity planning, and we're coming along on this effort fairly well. Teams have to go off and instrument their code. So we have the instrumentation framework in WMI, but we've got DS to do it. We're trying to get IS to do it. IS is working on instrumentation. We have to go off and get other teams to instrument their code. Because all of it has to work on retail binaries. We can't go to a customer side and say, look, I have to go back and bring some binaries to go back to corporate, bring you some binaries and try it there. Visualization, we're trying to work on some visualization tools just to make it easy to abstract from the data we collect. That's another thing we're going to have to keep working on. And of course, all of these we'll have to continue to improve on these. As things break, we'll have to try and fix these. We're just trying to work on this. We have to have better workloads, and part of this will be what doesn't work for a workload. Maybe we'll have to go off and fix, then we have to go off and look at more and more customer sites and see what doesn't work there. But what we saw was that 30% of the cache misses in the static case or in the ASP case accounts for most of the CPU usage. Compared to the 30% of cache misses, your 70% of your hits are coming virtually for free. Well, not really for free, but you can think of it as 70-30. 70% of hits are 30% of the CPU usage, and so on. And our new workloads are incorporating this. And we have to look at more and more customer environments. ISPs, the hosting issue, which we don't do particularly well in today. And there's a variety of reasons for that. The .coms, to go off and see what are they doing on their sites. MSCOM, clearly, that's a huge IS customer. We're looking at our new workloads, incorporate the miss rate into the workloads, look at ADO, look at multiple sites, and XML, clearly. And XML really has to be part of what we look at. It's such a big CPU hog. We have to look at this. That's essentially what I have. Yep. Sure. Can I take this off now? Can I take this off? Okay. I've got to be careful what I say now.
The first question is I'm interested in, it's probably less to do with what other people are interested in. I just want to make sure I understand what I think you're saying. So, if you had a profiler from somewhere that was an attributed profiler that could profile an application without any instrumentation at all.
Yes.
And there was no file generating, you just gave the data immediately. Would this satisfy a lot of your needs in this space?
It would be one big step. Clearly, we'll run into other issues as soon as we do this.
Yeah.
And going back to this process, as I said, the whole process, you can see that this process wasn't very good at solving the MSCOM problem.
Oh, absolutely.
Right? I am very scared that all it took was, I just had this thing, okay, misses are a problem. Go off in the lab and do this. Well, I thought misses were a problem because I'd been fixated on misses for a year by that time. Okay? Had it been something else, we would possibly still be looking.
Right. So really what you're saying is the profiler just totally failed in this space because you couldn't use it.
The data was wrong. We weren't getting any attributed. We weren't getting any attribution. We weren't walking up the stack. Yes, it told us the heap was a problem. Yes, that was a big help. But
if you had a choice between doing things like that to the profiler and IA64 support, which would you pick?
between fixing the profiler and IA64 support, can I turn this off? Which would I pick?
I'm just curious.
Both of them are concerns. Yeah, okay. Non-binding is the key here. IA64 support is very important. We'll have to see how IA64 gets picked up in the marketplace. If it turns out that IA64 is really important and we have to direct all our efforts at IA64, yes, we'd have to go with IA64. Unfortunately, so much of our installed base is x86 IA32 that we have to keep looking at performance problems.
So I'm hearing one thinks a long-term problem, the other thinks a short-term problem.
An intermediate problem. I don't think IA32 is going away. Again, as I said, this is right. We don't know how well IA64 will perform. I think there'll be a host of performance problems with IA64 well before this gets to customer sites.
Okay, so I think I'm finished with the profiler. So could I drill on one of the things?
Sure.
What would be your feeling if PDBs disappeared and they put symbols in the exits? Would that have saved you a significant amount of time?
It would have saved us a significant amount of time on Microsoft.com. I can't say what other issues this will generate. Right? We've been over this with people don't want symbols in the binaries because they don't want to release them. Size of the binaries,
Yeah,
shipping fees. Yeah.
But an MD5 ought to be able to match up to a binary with its symbols correctly, so you know at least that you have correct symbols. I mean, that should
Yes.
be an issue.
You would know when you have incorrect symbols.
Exactly.
Right? But getting to the point where you have correct symbols installed, especially when you're putting in binaries, taking out binaries, you're panicking because you're told everyone IS5 is faster and it's not. Right? All these issues.
That spells that some of that work on symbol servers basically to automate that process and solve that problem. Are you familiar with that?
He did, and I don't know how far along that process was when we had to deal with MSCOM and how much that would have helped, but yes.
When was this?
This was September, October.
Private binary symbols don't make their way to
Yeah.
the symbol server. But you were saying earlier that you
Also-
don't have to replace binaries on the machine at all.
Absolutely.
So the symbols issue should be.
Yes. But
That's where some go away if we can
Well-
simply profiling without instrumentation.
we would like to not to have to, but we will.
But there was some product symbols there.
Right? Again, this was MSCOM, right? And they are not. There's no way to get from MSCOM to corporate. There's no way to get from Realtor.com to Microsoft to
If there
the
was
build
retail
service.
product symbols, then it wouldn't have been an issue.
Yes. I would like to be able to do away with private instrumentation, private binaries, but I know that's not going to happen. So the issue will always be there. Again,
What if private binaries always have symbols in them? Retail ones
absolutely.
wouldn't have.
That would help. Yes. One.
Asking PC to do that, though, is going to be...
This is not clearly ours is not the only concern driving this, and I fear ours is not going to be the concern that decides this. One thing that worried me entirely, as I said, was going back to is just the process. Today we don't have a good way to take a problem that comes up and drill down in any logical, organized manner to say, okay, well, we get to the heap, right? And from there, where do we go? Maybe if we had good attribution. Oh, kern rate, it just said right away. Once we had bad kern rate data, so it threw us off for a while. But once we got the correct data, it didn't take us long to get. This is the heap. Went off and got some private instrumentation. No. It took us 3-4 days to figure out that the heap was a problem. It took us a lot longer to figure out, to get the instrumentation so we know the MSVCRT heap is a problem. Now, why is the MSVCRT heap a problem? And that was the part that we couldn't because we didn't have any way, again, to attribute the activity, the ASP cache miss, to the heap usage. It was causing the heap fragmentation. It was causing to all the time it was spending in the heap.
So I thought the MSVCRT heap was a pass-through on the G5.
When I'm talking, when I say we're talking about the MSVCRT heap, I really mean the heap created by MSVCRT.
But it's still RTL.
It's an RTL heap, yes.
So the best that sort of could be done with something like IceCap would just be to go for no instrumentation profile. You still got the symbols problem.
Well, no instrumentation and no overhead.
Yeah.
It's a stack walking over.
Yeah. So what's the definition of
In the couple of percent range is okay, right?
A couple of percent is absolutely acceptable.
Has anyone really measured what the benefit of FPO compilation is in the system as opposed to leaving all the EDP frames in so that we can always get good stacks?
I have about
5%.
There's a size issue, right? We're looking at there's the size issue on a desktop memory constrained system. There's the size issue on the server where you want cache locality. So both of those eventually get some I would say it would depend on the workload, but I don't really have good data to tell you.
So was V2 now an option for finding where the problem was?
We had, I mean, in a way, we're fairly lucky that this is all Microsoft internal. So go off and get internal binaries and go off and get data and instrument whatever we could. We actually put instrumentation in the heap, so Adrian's instrumented heap would actually dump out which heap was taking time, what sort of allocations we were doing, how many hits, how many misses. It was fairly good instrumentation. Yes.
At that point, that there was a problem with a certain heap taking a long time.
Yep.
Okay, and you're saying that even at that point, it still took a long time to figure out why.
Yep.
Okay.
But it took far too long to figure out why, even going from there.
I mean, in fairness, the fundamental problem is quite hard. Diagnosing heap fragmentation is, I think it's trivial. It's not like, oh, I stuck 0 in the wrong memory location.
Quite a few things done.
But instrumentation there, that was the problem.
Apples to apples instrumentation on MP4 and MP5 to say, what's the average time of an allocation?
Well, and the fact that the call trees
Well, we didn't know.
pressure go down on one heap.
But part of the problem was we didn't know the core trees were different. Right? Because everyone's going off saying we didn't change anything with the heap. Right? So and clearly it's not something you can rely on. You can say, okay, everyone says I didn't change anything in the code. Well, something changed, but it would be nice to not have to go back to the code and do a diff and figure out what's changed.
But with an attributed profile, you should have been able to find that fairly easily.
Yes.
You should have seen that the call time was dramatically higher. Now,
Yes.
that didn't tell you that they changed the architecture, but it told you that it stopped and that it was like
Well,
3 times longer.
What it would have told us is that there's a lot of time from malloc or new or whatever they were using, local alloc, or whatever it is that they were using to call into the VC heap. That was taking a lot of time. It wouldn't, even an attributed profiler would not have told us how many calls were made to alloc. Right? A profiler, I'm not talking about a trace.
Oh, right, okay.
Yeah, if you're just doing sampling profiling, yeah.
Yeah, right.
It's one of the things this gets to is the difference between a sort of open source based environment where there's conferences. Oh right, gotta go build the instrumentation, which is actually what wound up happening here, or a tools based environment where where basic thought is, well, we can't modify binaries, etc. We have to have tools which without the change
true. But
when you say that you don't want to modify the binaries that are there, can you assume, though, that you at least have the full PEBs so that we can do full analysis of the binaries on the customer's machine so that we could know what the stacks should look like, et cetera? Or do you want to be able to work on any third-party binary when we don't have any debug info? Because there is a big difference in how we can structure our tools.
well, it's going to be a question of what the tools are targeted for. If they're targeted for internal work, yes, then I imagine we could. But and if it's someone working closely enough with a customer to solve whatever performance problem the customer is seeing, then perhaps we could get PDBs from the customer as well.
Is the end goal just to get customers to actually do the analysis on their side so they never have to call us in the first place?
Not down to the customer level, but perhaps the field could do quite a bit of, if they could do quite a bit of the work.
I think that would be the barn that would make a big picture.
Well, I don't think that's going to happen. And clearly there has to be some feedback. This is what we learned from one crisis. As we go forward, fix some of the things, we'll run into more problems. Just the next problem waiting to happen.
How often do you have a crisis about
This size. Microsoft.com was fairly big because it got escalated up to as a deployment blocker. It's like, we are not moving to NT5. And they put their foot down. The next thing that hit was actually the TPCC crisis. Which was, again, it's internet, right? So it gets stuff done because it's the middle tier, it's a nice API. The problem there actually turned out to be the heap again. But the problem there was we had these numbers ready to publish, the compact numbers, the same ones that have been recently got pulled. We had those numbers ready to publish for launch. But compact had been running everything on, I think, beta 2 of 85, and then went to RTM. And they couldn't get the same numbers. So.
And the numbers didn't suddenly get better.
Well, what happened? Well, there was again the issue was that heap was getting fragmented again. There have been some changes that have gone in.
When you see heap fragmentation, there's two ways they can show for your times. One is just allocations take longer if you have to look.
Allocations increase.
Search out the and the other is that just everybody who touches the objects allocated take longer because of lack of locality, either in cache or in paging or something. Do you ever see the second kind of problem didn't happen in the MSCOM case?
Well, it's hard to say just because the first one is such a huge hit.
Right.
Because you're walking through the free list. Or whenever you free, you're going through your coalescing, you're doing or you go through the free list and you don't find what you're looking for, you have to go to virtual memory. Right? Just because that is such a big hit, it's unlikely you're going to see the second. The second one's just a secondary effect. It's just,
I have measured in some apps. In AST, you can show that like a 30% win or changing out the heap, that only 15% of the time is, only 15% of the improvement is calling marking through. The other 15% looks like it's the fact that the layout is different and better. It just makes the app run faster. But when you try to analyze that 15%, you can't find it because it's sort of, it's a 10th of a percent from 1,000 holes in the floorboards. It sort of oozes out. Just cache misses that don't happen all over the place.
So with respect to lifetimes, which is causing the fragmentation problem, do you see a pattern where certain ranges of sizes, maybe longer lifetimes, whereas certain ranges of sizes, like really large allocations, may be short lifetime? If the heap can sort of learn what size ranges are long and short lifetime, maybe you can reduce its own fragmentation over time.
It would be nice if the heap could auto-tune. Rick Visick is looking at heap auto-tuning issues. The problem again is just getting changes into the heap and learning from them. Everybody uses the heap. It's so hard to say, okay, these are a few important workloads. I'm sure it could do better, just I don't know how much better we could get with auto-tuning.
The problem with whatever you do, someone comes and whines at you. I think Neil had a great style. No matter what you pick, everybody wants something different out of the heap, and they all think that it should be tuned for them.
I for one, I have no objection to people putting in private heaps into their code. And it's great. You find one that works well for you, go ahead and put it in. For one thing, you're not going to come complaining to me, saying the NT heap is slow.
Sure, but it makes it harder to debug later.
Well, that's part of the problem. And
I'm going to have to put you in contact with PSS.
that unfortunately, that's. And again, we were part of the problem. We told everyone, go ahead and cache allocations. Of course, we weren't even thinking about, okay, they're going to be caching allocations from a shared heap.
So this is one of the interesting things. There's a really bad under budget for a lot of innovation. It's been known that the heap has been bad for heaven knows how long. So people develop all these compensation mechanisms, all these higher level workarounds, and then that starts to cause second order problems in two ways. One, it leads to these problems. And two, it makes it harder to now just make progress by replacing this low level thing. Once you get the crappy workarounds on top of the crappy understructure, now even if you replace the understructure, you may not be helping the overall problem.
And even worse, it masks the process in diagnosing the problem. These patches mask the underlying cause.
We had this. We're talking about crises. We had another one where on Webbench. So Ziff Davis went off and ran CGI SSL over CGI over SSL, and they were starting to see a memory leak. And part of the problem we're trying to debug that when it got dumped on us again was the SSL part caches allocations. So what was getting leaked had been allocated ages ago, or the path that was leaking possibly leaking cached allocations. So you didn't see it as part of the problem. So.
With the Windows Media Player.
Right, exactly. They had exactly the same problem with Windows Media Player. And tools like Purify that supposedly tell you about, leaks or whatever, don't catch that because you're still holding the object. It doesn't know anything.
And the interesting thing is that a garbage collecting system also won't help you with that because
Well, you can hold. I mean, generally, when you create an application, garbage collector.
You're confusing. You shouldn't.
Okay, fair enough.
Because when I talk to people,
right.
like I know people who use Great Circle, I've swapped that into their C and C++ code. Man, memory utilization continues to grow over time. Why is it? Is the garbage collector broken? No, you've got stuff like this. Java. There's no reason to assume that C# will be different.
Well, I mean, it's a programming style. I think the bottom line is whether or not people have this perspective that they have to have private heaps because they can get fast allocation.
It comes down to the same thing every time. Memory allocation is free. That's what every application developer believes. It takes 0 cycles. I know what it does. I didn't write the code, so it's free.
But
that's the same with all OS calls. I feel sure they found something exactly the same.
Well, not all of them, just the rest I bounce off on other people. Oh, that's Rick, or that's talk to Reza.
So let me ask sort of a related question about it's more of a meta level question. If you had tools, so there's two spaces of tools that you can imagine. One is making sort of tuning a particular piece of software to make it a little faster, IIS, in whatever environment, okay? And the other is dealing with these big problems that come up, which are sort of catastrophic. Okay? And sort of you can make the 5% gains a little at a time, or you can deal with these big crises. Which set of tools is more important in your mind?
We have to have both.
Okay.
Because we're targeting different concerns with these. I talked about the benchmark issue, right? One of the big problems I see what we look at is we spend so much time with industry benchmarks. We don't have the same sort of time to spend with customer scenarios. Okay. Why do we have to spend time with industry benchmarks? Well, you can read the mail today, or you can talk to the marketing guys. And it's part, and then again, when we do well at some industry benchmark, we do go off and beat the drum for it. SpecWeb 96 was a useless benchmark. It didn't tell you anything about anything, but we went off and said, look, IS does so well. And the truth of the matter is, we did not let IS handle any of the requests. We had we had a kernel mode driver caching as much as it could, right? Because we knew second IS touches this stuff, we're not winning any benchmarks. The only time we let IS do this is with the ZIF Davis benchmarks, because we've traditionally done well with them. They go off and do ISAPI, and again, this is the sort of thing that we'll be playing a lot with, and the highly tuned caches that we write for some of the other benchmarks aren't going to do so well in the hands of the reviewer. So that's one of the reasons we have to let. But customers aren't going to be picking up these web caches. They're going to be picking up IS, so we have to look at IS. They're going to be running into the sorts of problems we cannot abstract from. And they're going to be running into these sorts of problems where they're leaking memory all the time, or their ASPs crash on them because they've leaked memory and eventually the heat just runs out of something or another. And that will always be with us, but then again, we have to go off and when NT6 comes out or NT7 comes out, marketing has to be able to go out and say, look, it's 30% faster for your web server, go off and buy it.
Performance sells in that way.
Sorry?
I think it's an argument that performance sells in that it's one thing to say to people, buy our new product because it's got this new feature.
Mm-hmm.
They think, I might use that one day. If you say buy a new product because it runs your existing stuff 25% faster,
Mm-hmm.
most installations it's a slam dunk with this product straight on.
Especially for server products.
With desktop running 20% faster, it would matter because you already have the desktop,
Mm-hmm.
It's running just fine, and the load in your desktop is not going up, whereas loading your servers is.
Well, actually, it is, right? All the features that we put in. It does.
Right, so we'll just cancel out all the additional features. At least the number of users in your desktop is not.
Okay.
So one of the points of this forum is we've got this NGWS
Yep.
thing, which we all know what it is, ha ha ha. So what do you see as the really terrifying aspects of NGWS? What are the things where, when you hear about things to talk about, you go, oh no, we're all there?
XML right there I mean, the XML, I mean, this is both. I mean, you can take, basically this is what we're saying. We're saying, this is a text format, right? It gives you, there are a lot of good things about having a text format, but you're saying, look, your Word documents will now be XML. Well, guess what? They're going to be 3 times the size. Right? Your nice compressed binary format is now this big XML file. And I don't know if people have thought about the I/O implications. I'm going to read it off a laptop. Right? This is a slow disk. If I have to read, my 300 megabyte file is suddenly a gig, and I have to read it off disk.
What about standard encryption? Standard encryption for XML, where you have all the tag words and everything is common, sort of the static prefix dictionary.
Sure, but you still have to have them, right? You still have to have them in your text. You can have them encoded, but it's no longer a text format. Then you're going back to another format.
I understand getting it off the disk would be faster, but the in-memory footprint would still be just as big, if not bigger for the decompressed overhead. But is that where the problem is, or is it just getting it up and down the wire? And all
No. The 2 issues. One is, of course, going to concern our workstation buddies more than it's going to concern the server side, is just the I/O it's going to take to get it off the disk, get it into memory, all the footprint. The other issue is, as you're reading it, you have a translate. Right? If you conceivably, and I don't know enough about our Office formats, but if you had your own private format, well, you could just, it could be tuned. Whatever you're doing to read it could be tuned to read in this format.
So do you think that the size of the parse time is the bigger?
The size is going to be an issue on desktops. The parse time is going to be an issue on servers.
So what do you feel the point of attack is here? I mean, one argument is you could go and assassinate the committee that's in charge of XML. One thinks that's not a good choice. Yeah, it's a
of them. Unfortunately, focus is hard to do with all of these things. We'll have to go off and fix our XML. We know very well XML is not going away, at least for the next 2 or 3 years. And it has very high level support within the company. So we just have to live with it, we have to fix it, and make it as fast as we can. If we may have a competitive advantage in that, XML is going to be bad for everyone. It's just not.
So why not buy Microsoft? Sorry,
If it's bad for everyone,
then you should buy Microsoft.
yeah. If we can make it.
So if we can get to the point where we're no worse than everybody else, we have an advantage.
That's unfortunately that's reality in a lot of these cases.
Just sounds bad when you say it out loud.
So what I'm hearing you say is, given those limited resources, we should focus our thoughts on making XML least worst on our machine, on our software.
Yes, and we have to attack it from 2 different ways. And traditionally, components like this have been a real pain to deal with. It's things that are going to run on the server as well as on the desktop, because we have 2 sets of possibly conflicting concerns here. One, we've seen this with Olay in all its, up and down, COM, Olay automation, Olay 52. We've seen this with VC run times. Yes. Okay.
One of the things that made this really hard is that there was, in some sense, the problem was not caused radically accentuated by these things. It was nominally independent components, both wound up having this very unexpected dependency that they both started hitting the NSBC package key.
Yes.
So one of the things that, as the platform gets bigger and richer, there's all the more opportunity for these unintended consequences, and we have this.
Yes, and again, server-side applications need to take care of this themselves. They know they're hosting. If you're hosting a lot of components, don't stay away from what they might be using. If you have a private heap, nobody else can use it. So for server components, or even, for instance, a private heap implementation, right? Nobody else is going to go off and use it. I think the onus really is on server-side applications to not use weak components, to not allow weak components to interfere with their own operation. Sort of isolate themselves from what they might be hosting. But that's difficult to do given time constraints and other shipping constraints.
So you said before, the world's going to be fixed in black code.
No. They say cannot be fixed until black code. I did not say it will be fixed.
Yeah, because everything else was fixed in Cairo, right?
Yeah. I worked on OFS. Don't talk to me about Cairo.
I know. So I was just curious on what that meant in terms of dates. Just because I'm interested to get a sort of time horizon.
You've been talking to Adrian, right? I know you've been talking to Rick.
Yeah, I've
Who
talked
is
to Adrian, but I don't know anything about black code. I'm thinking actually more to do with profiling and everything else. I mean, what I'm hearing is the world's going to radically change in black code, and that seems like an opportunity window that we can work in.
I don't have a lot more information for the dates. We are. I think the list is out there on the Blackcomb feature list, and the Blackcomb schedule is up on WinWeb.
Okay.
So, again, it's so far out that it's probably not worth the disk space it's using. That's what they say right now. I don't know if it's 2002, 2000. Again, as you said.
2002, so
2003.
No.
Next issue.
And you said something about Adrian?
Adrian on Rescue? He's been looking at heap alternatives. I think you've spoken to him.
Yeah. But we
And he had been dealing with heap alternatives. But again, I said, all of this has been pushed back to Blackcomb, so he's working on other things now. No, he still owns the heap. Just that other things are considered more urgent. Oh, well, if it's not changing in WSDA, then they.
I just want to check with you about burn rate. It points out to the heap right away, is that right?
Yeah, I'm sorry?
Burn rate.
Yes.
It points out the heap is a problem right away.
Absolutely. Oh, you could see all the time. Well, yes. Once we got past the problem with the incorrect data, once we got kern rate working correctly, right away you could see RTL allocate heap, free heap, and so on. All the heap operations showing up loud and clear.
But from that point to the point where you get the problems fixed,
It was a while.
you needed more tools to deal with it?
Absolutely. We didn't know which heap because there's so many heaps in the system. It was all RTL heaps, but the.
So a simple, one seems like when you create a new heap, it should be that you have a lot of time in some sense. It's an infrequent operation. Seems like associating some kind of information about what was going on in the context of the creation would be a straightforward thing to do. And that would help your problem, presumably, right?
Well, yes and no, because all the heap of the functions, the RTL create heap is the same for all the heaps.
Sure, but you can figure out your calling context.
Well, we didn't have a kern rate doesn't have a calling context.
No, I know, but I'm saying in the code for create heap.
Yes, absolutely. Yes.
It could do almost anything at that point. Now you're right. The symbols are a problem.
We can actually. It got to the point. In fact, the heap has been such a problem for so long. On NT4 and NT5, I could tell you from the address of the heap which heap it is, who's created it. The process heap is 70000 hex. There's and so on. So there's the VC heap, the heap that MSVCRT creates, and then there's some private heaps that IS creates, and you can tell just from the address of the heap who's created it.
Okay, well you can tell.
Well, look at it a few enough times, or break on RTL allocate heap, and you'll know if it's a private heap, you know who's calling it. It's not that hard. It's just figuring out which of the heaps is taking all this time.
I see.
And once we got
the operation on the heap. Okay. Yeah.
Well, see, if there's a blizzard of heap operations, you see thousands of allocates, and you find out later that 10% are on one heap, 20% are on another heap, 3% are on the third heap, like 10 heaps, and then one of them's taking 70% of each fragment. It really can take a while to figure that out.
I was going to say, one of the interesting things though is that it seems like for things that take a long time, like if you're walking down a long linked list, say, and you've gone 1,000, you've gone down 1,000 elements, something like that. I mean, at the cost of doing that, you can amortize the fact that you're spending a lot of time doing a particular operation with finding it, sort of recording some fact about what you're doing in some sense. So it seems like instrumentation that where the cost of the operation you're performing is proportional to the amount of information you retain about that operation would be very useful.
So in that case, you end up logging information about this new operations, which
right.
is what you want.
What?
Which is just what you want.
Exactly.
Well,
that's what I mean. So it seems like a style of design that says every time it takes me longer than X to do something, which I don't expect to take me very long in the general case, I should record the fact that what I was doing, because it took me 1,000 searches anyway. The extra two cycles or
that could end up slowing you down when in the situation when the system's under the heaviest load.
Sure, but you're going to die anyway, right? I mean, that's
but they didn't know. You see, the problem is if they anticipated the problem, they could have done something about it. It's the issue when you don't know the causes.
You do know. Well, I mean, I believe in this case it was going down. It was a long linked list.
Yes.
Right? Okay. Yeah.
And the problem with what you're suggesting is this: now we know that the heap has a tendency to do this.
Right.
So now what Adrian's gone off and done is he maps the entire that list. Those lists are no longer long.
Right.
He has a lot of short lists now. Right? So if you go beyond a certain size in the heap, he will just map. He'll just break up this long list into many short lists. So when these things break and we figure out these things are going to break or these things have a tendency to break, we'll go off and fix it. So instrumentation at that point, it's trying to figure out, the problem is trying to figure out what is going to break. And of course, if you knew what was going to break, you'd go off and fix it in the first place.
You were talking earlier about all the people that have instrumentation into their retail binaries that would ship.
Yep.
Is that kind of to solve this sort of problem, or were you thinking of some?
So what we're looking at with that effort is to get higher level information. It says this particular ASP script took 18 disk IOs, 20 million CPU cycles, did 8 network IOs, took, well, I guess the locks would be 2. We don't want to estimate the locks. No, this is WMI tracing. This is the capacity planning effort. So it's really directed towards, it comes from the capacity planning folks. So they really want to know, okay, your average ASP script takes this much in terms of resources, you want to plan. And the nice side effect is we can tell, okay, this is a badly written ASP script, or this is a very expensive ASP script.
So if I'm hearing this correctly, there's a sort of model here that's going on. That at a customer site, the first thing you can go and do is go and look at the WMI data. So
you can turn it on. You'd have to go turn it on first.
Then the next step would be, ideally, some nice profile that will say the system-wide, this is where the time's going, go DLL, go exit. Then the next step is, okay, I want to know that this process with its functions, right down to the function level. Is that what I'm hearing? It's a sort of,
yes, and the third step would take a lot more than. So we would hope that by the time we have the WMI data, we would know these are the expensive operations. CPU, weight, or we can tell, okay, while your thread was executing this ASP script, it had 400 context switches, which is not that uncommon. It's very so once we have that sort of data, then we have to decide. And right now, as I said, the process is enough of a problem. We don't know where we would go with that data. If it's something obvious, it's something that we've seen before. Obviously, we don't need to get the function traces. We could just try whatever we've tried, whatever we've successfully tried in the past. It's when all of what we know about, if you can't reduce it to a problem we already know how to solve, that's when we have to get more data. And it's hard to tell how that would get solved. Yes, perhaps function level information would help at that point.
That's the last gap. Like geo that was going on.
Yeah. But that becomes so intrusive that.
No, it depends on what you think of. I mean, if it's sampling, that's not a problem.
Yeah. But again, getting counts can.
You can't get core count.
Yeah. Well, we could get core counts as well, right? Except you wouldn't get the trace. You could get the counts. You could still do something like, you could have a prologue that just upped a count and a flat count.
Style?
Yes.
Okay, sorry, I was thinking about the support line here. Absolutely no instrumentation.
Yeah. Okay. Yes. Yes. Without the instrumentation. Yes. Absolutely. Yes, you're right. Without. And so in that sense, it's not really a lost cause. We may have to take it one step further and put an instrumentation all over again. That's the.
Neel, one of the things that you mentioned was that the load is not very representative. The loads that we tested in our lab is not very representative.
Workloads?
Yeah.
They have helped us bring up the performance tremendously because they're easy to abstract from. It's okay. The static. Here's a static hit. Here's a static miss. The ASP stuff, we were looking at just one. We were looking at we pulled it off from Microsoft.com. We were looking at a single ASP in isolation. We didn't think about the fact that there are customers that run thousands, hundreds of thousands of ASPs. We think, maybe around 20, 25. And that until we went to Microsoft.com, it didn't register that the cache, the churn in the cache, can be this destructive to your heap. And that's why I have to go back and say, well, yes, what we had been looking in the lab was not. We've gone off and changed that. We have new workloads that really stress these parts now.
Do you have a process in place to make sure that that you're up to date with what customers are doing now, or did you just update it for this point?
No, we have to go off regularly, take a look at what our customers are doing, and then try and update our workloads. One of the good things, the best thing about having a workload in the lab is you can compare.
Yes.
Customer workloads keep changing every day. So you want to have, you can't show improvement or you can't direct improvement without having a fixed workload in place. How often do you change the workload? Well, as often as need be, but not often enough that it becomes useless for performance work.
So using BPS, the business partner solution guys as a test lab, is that practical?
I haven't talked to them. We thought about using Hotmail. And we may do that. A lot of the we use Barnes & Noble a little bit. We've had early adopters, and that works fairly well. But it's hard to go on a customer's side and say, okay, I just wrote this binary. Can you take it live? NotSom's been really good. They actually they set up something in our lab. That's just their. They set up their environment in our lab for us. So, can.
How useful do you think measurement tools might be to you? For instance, how valuable do you feel the data would be? This is the change in the basic blocks that are getting executed over time. That is, these pieces of code are now being executed and they weren't executed last week or last month. And these pieces of code that were executed last month or last week aren't being executed anymore. How valuable data do you think of data like that?
How easy would it be to correlate to something easy to work with? If I can say, well, I can see cases where this would help. Say, okay, the ASP cache replacement is being hit harder now. If I knew the basic blocks that we're looking at on these, if it's say some parts in TCP, for instance, somebody could go off and look at the code.
To go back to the source,
it would have to go back to the source and see this.
Part of the problem I've noticed is if you can characterize the workload, you would be far from solving the problem at all.
Yes.
But not to the point where you've got 1,000 hidden server on a server, then you start noticing a certain pattern of degree of degradation you can see, and you can start going back and fix it. But without that step, I don't think
there was no solution without that step. I mean, we probably would have got some other solution down the line, but it would have taken a lot longer.
We're trying to figure out any tools that can help you to get to that stage.
As I said, the process itself is very ad hoc right now. It's very seat of the pants. And part of it is just all the variables in a customer side in the code, what might have changed. We're looking at what's changed from NT4 to NT5. And Mike?
Sorry, I didn't mean to interrupt you. I was just thinking, I mean, Neel mentioned Rick Bissell before. He was the lead on the SQL product for many years. And one of the things he said on one particular music day was SQL performing like a snail. And we tracked it down, it's been ages tracking it down. And it finally came down to a piece of code that he'd written. And he blurted out, not thinking, he said, if I'd known they were going to do that, I wouldn't have written this code. And I think that's actually the fundamental problem again and again, that when you track it all the way down, the developer wasn't connected to reality. And I don't know how they ever can be.
Well, sometimes we are in the middle, and sometimes we are the problem. Right? We're going off and telling people, go off. This is really, we have to take the hit for this. This is the cache, the allocations. And of course, we didn't make it clear. Don't cache them from shared heaps. Right? And then, of course, you go tell it to one set of people, next set comes in. They know that we're caching allocations, and it's good because the heap is expensive. They don't know not to do it with MSVCRT.
And then you get the next iteration that you tell somebody something, and then they tell it to somebody else, and you get Chinese whispers around the company until it comes back back into this, whatever you do, you know, the cache allocations. Huh? We never said that.
Well, a lot of times we said things 5 years ago and they're still viewed as common wisdom.
So here's an interesting question. Why is there, or maybe I just don't know about it. What is there a central sort of best practices repository for information about the heat?
Everyone has his own.
Okay.
If you go talk to David Fields, who's in the desktop side, on the workstation side, in the same team, he will say, don't create any private heaps. Everybody go to MSVCRT, nobody link to libcmt. Size is an issue, and for them, size is an issue. They're looking at, their competitor is Win9X. Talk to me, I will say, write your own heap. What are you looking at the NT heap for? You're a server application. Right? Don't, any system, one system call that you make is one system call too many to make. And so we have this range of views, and it doesn't, not everything works well for every application. For IE, for instance, should really be sharing as much as it can with, should be playing with all the other applications in the system. IIS should not be, unless there is, I can't think of very many reasons why it should be playing, should be sharing a lot with applications that it's not directly tied to.
But at the higher level, I mean, I think Ben's a really good point in that I bet you there's nobody in the company who knows all these things. Who knows, well, I think of you, I suppose.
No. I mean, we're supposed to, and again, we learn something every time we hit one of these problems. We learn, and we have mixed messages going out of the anti-peripheral.
Yeah,
And so from that, it certainly follows that there's not everybody who knows it.
Let me give you an example. One of the outings of an Rockwell in the early days. So we went over to NT Lab and we stuck it in Active Directory. My mouth dropped open when I found that they did 24 allocations and then blew away the heap. I never thought they'd do that in a month or so.
Well, and we talked to them about it, and it's just back and forth. They don't have a way to scrub the heap, and they lose track of their allocations. So they have to get rid of the heap.
So it's not a complaint, I'm just saying.
I know, but this is part of the problem. This is part of the. This is back to your point. There's this infrastructure issue. We're not providing them with a good heap that they can, and we're not writing good code on top of it.
Yeah, I was going to say, it's like, okay, so there is some set of requirements, okay, and it may be 1,000 because there's 1,000 different people that need a heap, okay, but it is a bounded number. And my guess is that if you actually started writing these down, it would be less than 1,000. It would probably be 100 or something like that. And I think your suggestion that people that write IS should write their own heap, I mean, I think there's a problem there because it's a complicated thing to do. Right?
Oh, absolutely.
Every time somebody does it, they do it wrong.
I'm not saying go off and write it. You pick up one. There must be at least 50 floating around.
Well, there you go.
And some work better than others.
And it's not just heaps, it's all these things.
Well, yeah.
It's string handling.
Yeah,
It's insertion. It's God knows what.
Yeah. Well, this one happens to be pretty critical in the sense that, you know, people run into it.
And as Mike said, people expect heap allocations to be free, and they're far from free. And we have seen, again, going back to the heap, we've seen bizarre cases. People have been complaining about, okay, you allocate 400K, then you allocate 400 bytes, you allocate 400K, then you free your 400 bytes, and all of a sudden you fragmented virtual memory, let alone the heap. So,
I'm not sure. So I know there's a big technology piece of the solution. That having an underlying heap, which is better, is good. But there's just this huge education issue as well. That for any particular implementation, there's going to be things you should or shouldn't do. For any particular application you're doing, there's things that factor in. I'm concerned about the desktop, and I'm concerned about the server. The choices.
I just agree with you that when we write so-called general locking in, but they don't make it so you can configure it out, which makes it useless for the desktop end of the world.
And this is treated for stuff that's designed only to be general purpose, like our STL implementation.
Right. STL, I think, is the king of
Unreusable.
Yeah.
Well, so wait, so how does garbage collection work into all this? I mean,
badly.
I was going to say, garbage collection, it sounds like garbage collection just won't work.
You were talking about NGWS nightmares, right? Here's the other one. This whole issue with managed code, I'm really scared about it. Just because I know this is going to be a big performance hit.
No. I went to the performance talk that those guys did today. They assured me that the managed environment is the easiest place to write high-performance code.
Talk to me in 6 months. They may be able to do better than ASP. It's not going to be that hard to do better than VBScript being interpreted on the server. Are they going to be able to deliver at the rate we will be advertising? We set up expectations. We go off, our marketing guys go off and tell our customers, go use ASP. It's so easy to write. Problem is, it is so easy to write. You take the guy that shouldn't be writing code, have him write VBScript code if you run it on your server.
You're making quantitative promises at PPRC about ASP+.
ASP Plus may have better. They compile it. They compile it into managed code, so it might run much better than. It's possible that it will run much better than ASP. Again, you're starting out from the ASP base, and that's not saying much. We've seen similar things with URT. Now, the one good thing about URT is Treadwell's in charge, and we have high hopes from him. I've dealt with him for a long time, and I'm confident we'll work with Treadwell. That's the one silver lining in this ominous cloud. We'll see. Sorry?
So I'm just curious. I mean, in one respect, the Windows 2000 team is more signed up for .NET than anyone else.
I have been signed up.
I know. Curious.
Yeah.
I mean, to what degree has any message come down as to what .NET is?
There has been. Well, we know some components that will be involved in .NET. Beyond that, there hasn't been much. So from a development perspective, what do you want to know? You want to know what components are going to be critical in delivering this piece, right? Oh, the rest is all PM and marketing anyway, right? So you want to know what XML's here. URT is going to be involved, but that's somebody else's problem or whatever it is. It'll come down to us, right? To what pieces it is that NT better be prepared to deliver on. After that, what is the bigger message? Don't know yet. I certainly don't know.
Well, it's nice to know that you're as in the know as everybody else.
Well, again, beyond making sure that these don't become the performance bottleneck, these pieces, URT, XML, I'm sure database connectivity will be a huge part of this. Okay. Thank you. Well, see if they've towed my car yet.